Hello everybody, my name is Suyashadikari, and this is my project demo from IT114 class. I did the chat room project. So, before starting up the clients, I had to start up the server in the background. Now these clients, they send a connection request to to the server, and they're automatically placed into the room lobby. However, clients can't create their own rooms. When clients create their own rooms and send messages through the input shown here, they send little data packets called payloads. Payloads aren't simply just like text that the program like parses through in order to find commands. Rather, they're data packets which contain a payload type, a message, the sender's ID, and the sender's name. In this case, it was a create room type payload. And the clients that joined room 1 sent a join room payload. There are a variety of commands that I have implemented within my program. One of them is roll. For the roll command, my client detects that my message starts with /roll and creates a payload type of roll. This is then sent to the server thread, which detects the roll payload and then is sent to the room, and then the room itself does all these calculations and then sends the message back in a purple text. I chose a purple text because clients cannot type into purple text. They can only type in red, blue, or green text. There is also formatting that my clients can do. They're not simply regulated to plain text. For example, there's bold formatting, italic formatting, underlining, and they can also set their text to different colors. So how this is done is the messages are all sent to the server thread, then they're sent to the room. The room parses the message for certain indicators, like this one for red, the hashtag R would be an indication for red. And since my chat panel, which is the panels we're looking at currently, display messages with in HTML, the room replaces the hashtag R with HTML code in order to turn it red. Like that. This is similar to how it's done for bold, italic, or underline. It looks for these special characters, and the room parses through them and then sends it back to display as like bold, such as that. I also have a private messaging function. So let's say A, B, and C are in the same room, right? But A only wants to talk to B. In order to do this, they can at B and then type a private message, whatever that may be. And as you can see, the message is only seen by the sender and the person who's supposed to receive it. C has no idea that A just sent B a private message. How this works is I create a payload of type. I create a payload type of private, and this is sent to the server thread. The server thread sends this to a specific it sends it to a specific method in the room made solely for private messages. How that method works is it iterates through, it like goes over all the clients and sees which username matches the words that come after the @. In this case, it would be the B, and then only sends the message out to B. There is also a mute function. So let's say theoretically, A would like to mute B. Now there is a message. There's a purple message that pops up, which again the clients can't replicate. So you know that a command was done where A has muted B, and now A can't receive any messages from B, while C can still see B's messages. And A can't receive the private messages from B either. As you can see, only B can see those messages since they did send a private message. C can't see it because it's a private message, and then A can't see it because A has muted B. But similarly, you can also unmute B. Now, the muting is not only does not only work in this instance of the program, it carries over. So, for example, let's say A mutes C, right? In my code, A has C written down, and whenever the room adds a new client, it has a command that reads mutes. Now, this read mute command will go back to the server thread and read this muted file, and will mute C if A ever reconnects. So let's try to work this. Let's see how this works in theory. So let's say A completely disconnects, right? But then A wants to rejoin, but they still want to keep C muted. So A rejoins. Let's say they join back to room 1, right? A still has C muted. So as you can see, A still has C muted. So C types a message like hi. A will not be able to see it at all. But A can also unmute C to see their messages again. And this will also remove C from A's mute list, as you can see right here. I have another function called export, and what export does is the chat panel itself, it takes all the content in like this area and writes it to a file. So let's say B wanted to export its chat, right? I'd click the export button, and we would go right here and see the chat logs. The specific code that does it is here. It writes the components of the chat area line by line, and then outputs it to a file. Another thing that I do have is, as you saw earlier, when someone was muted, their name was grayed out. So we can see a demo of this here. Let's mute C again. As you can see, their name is grayed out. Now, how I accomplish this is I send a mute to the room, which indicates who the client wants to mute. The room checks that the client isn't already muted, then tells the server thread to mute this client. This will prevent the client from receiving any more messages, because whenever the room sends a message, it has to go through all the clients and send a message. And if the muted client, and if the client has muted you, you can check the receiver's muted list to prevent the sender from sending you the message. So if A has C muted and C wants to send a message, it'll iterate through all the clients and check all their mute lists. We'll check B's mute list. If B doesn't have C muted, so B would receive the message. However, A does have C muted, so A would not receive the message. And the way the highlight works is that the room makes a payload, which is again one of those data packets, which is type mute. This is then sent back to the client, which is sent to the UI. The UI sends this to the user list panel, which then iterates over the components and sends it to the user list items. User list items finds the matching client that is muted, which would be C, and mutes that client by highlighting the foreground text in gray. This is a similar process as to how chat highlights work. So, for example, if B sent a message, as you can see on everyone's screens, the next to B is the color green. This is done whenever the client receives a message, so it gets the data packet contains the client's ID, and the client then sends this to the chat panel, and the chat panel itself contains a user list panel. Then the user list panel creates a button, and this button only goes visible next to the person that just sent the message, as it looks for a matching client and sets the button next to them visible and green, and if there's a non-matching client, it sends their button to invisible, which is this gray/white area you see here, because B just sent the message. Another fun command that I implemented was the flip command, which basically flips heads or tails, and you can also roll multiple dice. So the roll command works in multiple formats. You can either pick a randomized number to roll to, or you can roll multiple die, which will give you the end result of 108 as C got. The flip command works similarly to the roll command. The client detects a /flip, and this is sent to the server thread with a payload type of flip, which sends it to a specific room method, which determines the output. Then this is sent back to the server thread which is displayed on all the UIs. Furthermore, the text formatting that I indicated before, like around here, it's not just limited to one text format. You can have multiple text formats. So let's say you wanted to bold something, you wanted to italicize it, you wanted to underline it, and you wanted to make it blue, right? You are able to do that. As you can see, B outputted a message that is all bold, italicized, underlined, and is blue. Now, quickly going over all the class responsibilities. Usually, when the client sends an input, this is sent to the server thread, which is then sent to the room. The room detects that it's a message, and it loops over all. It has a list of server thread clients, and the room will then send it back to the server thread, which sends it back to the clients. And the client will then display it on the client UI. The panels you see here are done through importing Java Swing and Java AWT, which are separate packages. And this is the conclusion of my project demo. It goes over most of the major features that I've implemented. Thank you.